Okay, so now that we've done trinomials, we can go down to binomials. Binomials only have two terms, right? So examples of binomials are 3x plus 4, right? The 3x is a term, the 4 is a term. That is a binomial. Or you might have y squared plus 25. The y squared is a term, the 25 is a term, right? Or you can have, a squared minus 3b squared. Right? So all these are examples of binomials, right? Right. And as it turns out, all of these happen to be prime, although we don't really know that yet. So remember, when you're factoring, don't forget the GCF comes first. In this case, in these three cases, the GCF was always 1. But here's an example where it's not. Right? So suppose we want to factor 12w minus 18. Okay, so there's only two terms. It's just a binomial, right? And the GCF here, well, hopefully it's obvious by now. Should be 6, right? So when you factor out the 6, you're left with 2w minus 3. And that's it. Right? So, yep, sometimes they are just that easy. Although it doesn't have to be easy if you get confused, right? So here's another one. Suppose I have x cubed minus 8x squared. You want to factor that? Well, the GCF here, it's not just 1. They both contain an x. In fact, there's two x's, right? So the GCF is 1x squared. So when you factor out the x squared, you get x minus 8. So x squared times x minus 8. Okay. One more. Okay, so 21w squared times z cubed plus 35 times w z to the 4th. Okay, so this is a little tricky one, but hopefully you can find the GCF, right? Because 21 is just 7 times 3, and 35 is 7 times 5. So the GCF here is 7. And the lowest power of w is w to the 1. And the lowest power of z is z to the 3 here. Right? So the GCF is just 7w z cubed. Okay. Now, to factor that out, you just have to divide, right? So 21w squared z cubed divided by 7w z cubed is just 3 times w. And then 35 divided by 7 is 5. W divided by w is 1. So be careful you don't put a w there. It's just 5 times 1. And then z to the 4th divided by z to the 3 is z to the 1. Okay. And we're done again, right? So 7wz cubed times 3w plus 5z. Okay, and that's probably about as hard as it gets for the greatest common factor for GCFs here, right? All right, but there's other things we can do with binomials. Right, and the first is what are called the difference of perfect squares. The difference of two squares. And it goes like this, right? If you have a squared minus b squared, that will factor as a plus b times a minus b. Okay. So not a perfect square because, right, one's a plus, one's a minus. So you can't combine those, right? Yeah. And if you're not sure, you can always check. If you multiply this out, just use FOIL again. you're going to get a squared minus ab plus ab minus b squared, right? But negative 1 plus 1 is 0. So negative ab plus ab is just 0. And so that leaves you with a squared minus b squared, which is what we are starting with, right? So we're thinking about this backwards. We're looking at this and see if we can factor like this. Okay, so again, this is going to involve the perfect squares. Hopefully you remember the perfect squares. I'll write them down again, at least the ones that go to 100. All right, so let's see how this works. So our first example, the difference of squares. Suppose we want to factor 49y squared minus 25z squared. The first thing we should check is the GCF, and it's 1. Okay, so if the GCF is 1, now we look for perfect squares, and 49 is a perfect square. It's just 7 times 7. So this is 7 squared times y squared. And 25 is 5 squared. So 5 times 5 times z squared, right? But this is also just 7 times y squared minus 5 times z squared. Okay, so writing it this way, it should be a little more clear that, right, this is a squared minus b squared, where a in this case is 7 times y, and b in this case is 5 times z. Okay. So remember, a squared minus b squared factors as a plus b times a minus b. Actually, I'm going to put the a minus b first. So a minus b times a plus b. Right, remember, order doesn't matter, so if you switch the signs around like this, not a problem. Okay, so now we just fill in what is a and what is b here. Right, remember, a was 7y, and b was 5z. And same thing for the second factor. A plus b is 7y plus 5z. And that's it. We're done, right? So we factored 49y squared minus 25z squared as 7y minus 5z times 7y plus 5z. Of course, you can also write it the other way, 7y plus 5z times 7y minus 5z. As long as one is positive and one is negative, same thing. Okay, so that's how this works. Let's try another one. Okay, 64 minus 9y squared. Okay, GCF is 1. So now we look for, right, a squared minus b squared. So 64 is 8 times 8, so that's 8 squared. And 9 is 3 times 3, so 3 squared, right? So I think this works. Right? My a is 8, and my b is 3 times y, right? We're going to combine the 3 and the y. Right? So let's write that down. A is 8, b is 3y. Right? Be careful, b is not negative 3y, right? The negative is on the outside here. Don't put it on the inside. Okay. So if a squared minus b squared is a minus b times a plus b, then 64 minus 9y squared is just 8 minus 3y times 8 plus 3y. And again, there's a lot of different ways you could write this. You could write this as 8 plus 3y times 8 minus 3y. That's perfectly fine too. Or if you factored out a negative 1, you can write this as negative 3y minus 8 times 3y plus 8. Again, a little convoluted there, but that's another It's another perfectly good way to write the answer. Right. So yeah, if you thought that this was backwards here, right, that the original problem should have been negative 9y squared plus 64, yep, you can factor out a negative 1 and then write it as 9y squared minus 64. And now my a would be 3y and my b would be 8. So that works also. Plus 8. Can squeeze that in there, right? Yeah. So that would be another way to do this. Okay. Next one is 8h squared minus 50j squared. So how do we factor that? So little trick here because the 8 is not a perfect square. And neither is 50 for that matter. However, GCF, right? 8 and 50 are both divisible by 2. So the GCF here is 2. If we factor out the 2, we're left with 4h squared minus 25j squared. And now the 4 and the 25 are perfect squares. Right? So this is going to be 2h quantity squared minus 5j quantity squared. And maybe I went a little too fast there. Right? I mean, you're welcome to do that, of course. It's easy. Right. So yeah, everything here is a perfect square. So the 2h is what's being squared, and the 5j is what's being squared. So that tells me, right, a is 2h, and b is 5j. Right. And as long as you don't forget, a squared minus b squared is a minus b times a plus b. You should be able to factor this as, right, 2h minus 5j times 2h plus 5j. Right. Or if you switched it around and did the plus first, that's okay too. Oop, but then the other one's a minus, right? Yeah. So either way. Okay, so again, very important that you don't forget the GCF, because if you didn't do the GCF, then this looks like it's prime. It looks like you can't do anything with it. Right? So yeah, very important that you do the GCF first. Here it was just a 2. You know, in other problems it might be something more complicated than that, right? So we'll get to those as well. Okay. Next one is x squared plus 49. Okay, so here it should be clear that the GCF is 1. Now we look for perfect squares, right? So obviously x squared is a perfect square. It's just x squared. And 49 is 7 squared. 7 times 7 is 49. Right? So this is a squared plus b squared, right? Where a is x and b is 7. But that's a problem, because I didn't tell you what to do when you have a squared plus b squared. I only told you what to do when you have a squared minus b squared. So in the case of a squared minus b squared, it's a minus b times a plus b, or a plus b times a minus b. However, a squared plus b squared is even easier than that. It's prime. It cannot be factored. Okay? So, yep. So even though this was a set, right, 49 was 7 squared, right, the answer here is that this is prime. Cannot be factored any further. Okay? And not to confuse you or anything, but there are some instances where this may be factorable, but we're not going to worry about it. Okay? We're not going to do that. Whenever you see a squared plus b squared, when it's down to that, you can call it prime. Okay? Right. So, yeah, don't get confused with, let's say we had x squared minus 49. Right. So that is not prime, because now this is the difference of two squares, right? So again, a is x, b is 7. But because this is a squared minus b squared, this would factor as a minus b times a plus b. So in this case, you get x minus 7 times x plus 7. Right? Yes. But x squared plus 49 is prime. Right. And maybe you're thinking, are we sure it's prime? I mean, this a squared plus b squared, why isn't that just a plus b times a plus b? Well, let's check. Let's multiply this out, right? So a times a is a squared. Okay, so far so good. But then we have a times b, right? Remember, you have to FOIL, plus b times a, which is also a times b. And then we get the b squared. So we do get a squared and b squared. But we also get 2ab in the middle here. So that should look familiar. That's a perfect square trinomial when you get a plus b squared. So we've seen that before. Right? The key thing is, and you want to make sure you don't make this mistake, that you don't write a plus b squared as a squared plus b squared. That is a very common mistake. Please don't make that mistake. Okay? And the reason why it's understandable, right? I mean, I'm sure we've all done this. I know I must have made that mistake many times before I learned not to do that, right? And the reason why it's sort of understandable is because we do it when we're multiplying, right? If we have a times b squared, we can write that as a squared times b squared, right? The problem is it's not the same as a plus b squared, right? This is not a squared plus b squared. Right. Instead, we know what it is. It's a squared plus 2ab plus b squared. So if you're missing that 2ab, then it's just not right. It's not going to work. Okay. So yeah. So be careful not to make this mistake. Right. All right. So back to the difference of squares where we know this is factorable. Okay, next example is we want to factor 169r squared minus t to the 6. Okay. Yeah, so this one's not an easy one. The 169, if you take the square root of that, you get 13. So the 169 is a perfect square. It's just 13 squared, right? So that's one thing. And then the t to the 6, that is a perfect square. We can write that as t to some power squared. So what power is that? Let's just call it n. Remember the rule for exponents? This is just t to the n times 2, or 2 times n. So what number times 2 is 6? Of course, right? Just 3. Right? So that means we can write t to the 6 as t to the power 3 squared. So just erase that and put in the 3 here. Okay, so again, we're still hunting for my a squared and b squared. So a is going to be 13r, the whole thing squared, and my b will be t cubed, whole thing squared. So now this looks like, right, a squared minus b squared, right, which will factor as a minus b times a plus b. So here a is just 13 times r, and b is just t cubed, t to the 3. Okay, so we can factor this as a minus b times a plus b, or in this case 13r minus t cubed times 13r plus t cubed. And don't forget to check, right? If you multiply it out by using FOIL, you should get the original binomial. All right, try another one. Okay, 9x squared minus 81. Okay, so GCF is not 1, it's 9. Factor out the GCF. Right, so negative 81 is just 9 times negative 9. Okay, so having taken out the 9, now we recognize what's in the parentheses as a squared minus b squared, right? So a is just x, and b is 3. So this should factor as a minus b times a plus b. Notice I didn't write down the formula again. A squared minus b squared is a minus b times a plus b. If it helps you to do that, you can do that every time. Right? I'm probably going to do that maybe one more time, and then I'll just drop the habit. But that's it, right? So 9 times x minus 3 times x plus 3. Okay. Yeah, so if you didn't factor out the GCF, you might have done it this way. You might have said, look, the 9 is a perfect square, right? It's 3 squared. And the 81 is 9 squared. So my a is 3x, right? And my b is 9, right? And so you can factor a squared minus b squared. As I said, I'll write it down one more time. But in this case, this factors as 3x minus 9 times 3x plus 9. Okay. So what's wrong with that? Well, that's not the answer. Right? There's the answer. So you see the issue here. The 3 and the 9, right, are a common factor. So although this is factored, this is not factored completely. Right? Sorry for the mess there. So what would you do at this point, right? Suppose you have 3x minus 9 times 3x plus 9. Well, you'll get partial credit because it is partially factored. Right? This is partially factored. But from the first two terms here, you can factor out a 3. And from the last two terms, you can also factor out a 3. And 3 times 3 is 9. And that leaves you with x minus 3 times x plus 3, which is the correct answer, right? It's the same one as up here. Let's see if I can go all the way down here. Yep, same thing. Okay, so it's fine if you did it this way, but it's not fine if you left it like this. You had to go further. You had to factor out the 3 from here and here. Okay. So again, GCF. If the GCF is not 1, factor that out first because it makes the problem easier. Right? It's easier to factor x squared minus 9 than it is 9x squared minus 81. You're just dealing with smaller numbers. Right? All right, try another one. All right, so the next one is to factor x cubed minus 64x. Okay, so this is also kind of tricky because we're looking for a squared minus b squared, and I don't see a square. I see a power of 3 instead of a 2. So yeah, in this form, there's really nothing we can do with that. Right? However, we forgot again the GCF. The GCF is not 1, it's x, right? They both have an x here. So if I factor out the x, then I'm left with x squared minus 64. So there's my a, and my b. Well, be careful. B is not 64, right? B is the square root of 64, which is 8. Okay, so I just needed a little extra space here. So here it is again. A squared minus b squared is a minus b times a plus b. So now my a is x, and my b is 8. Right? I'll do that one last time, right? So x squared minus 8 squared factors as x minus 8 times x plus 8. And that's it. We're good, right? You can check, multiply it out. And even though I've been putting the minus in front, remember the first time I wrote this, I put the plus in front. And that's fine too. So, right, so x times x plus 8 times x minus 8, same thing. Right. Right. You can even put the x in the back, although that's not standard. And if you do that, you really should put parentheses around the x. Right? So the monomial term, the single term, usually should go in front. That's just a conventional place to put it, right? Okay, good. Next one. Okay. We want to factor 25n squared plus 45. Right. And yeah, so here again is the plus sign. And if you remember, a squared plus b squared, we're going to consider that to be prime. Right? It's only the difference of squares, a squared minus b squared, that is factorable. Right? Okay, so prime? No, not exactly. So remember what we skipped? We skipped GCF. And the GCF here is not 1. 25 and 45 are both divisible by 5. So I think the GCF here is 5. So we should factor out the 5, and that leaves us with 5n plus 9. Okay, so it is factorable, but not as the sum of perfect squares and not as the difference of perfect squares. So this was just a GCF problem, right? So yeah, don't get fooled. Just because you see a plus doesn't mean it's not factorable. It might be factorable by other means, in particular the GCF. Okay, so yeah, so if you put prime, it's not prime. You can factor out the 5. That's the GCF, right? Okay, now the 5n plus 9, that is prime. Even though 9 is a perfect square, right, it's 3 squared, the 5 is not. And even if it was, right, even if it's, 4n squared plus 9, that's still prime, right, because of the plus. Okay. So yeah, the 5n plus 9 is a prime factor, and the 5 is a prime factor. But that's the whole point, right? These are factors, right? So it's just like the number 10. It's not prime. It's the product of two primes. 2 and 5 are prime, but the 10 is not. Right? So the 5 and the 5n plus 9 are prime. However, the original question, the 25n squared plus 45, that is not prime. Okay, I hope that helps. Let's try another one. Okay, so factor completely x to the 4th minus 81. Okay, so 81 you should recognize as a perfect square. In fact, let's write down way down here. I'll write it one more time. A squared minus b squared is a minus b times a plus b. Okay, right, and this is a difference. It's a minus sign, right? So the tricky thing, of course, is that the x to the 4th is not x squared, but it is x squared squared. Right? Remember, you multiply these exponents. 2 times 2 is 4. Right? And then 81 is 9 times 9, right? So it's 9 squared. So that tells me my a is x squared and my b is 9. So I can factor this as a squared minus b squared. I'm sorry, as a minus b. So yeah, let me say that again. A squared minus b squared, right? So this is x to the 4th minus 81. A squared minus b squared factors as a minus b times a plus b. So a is x squared, b is 9. So x squared minus 9 times x squared plus 9. Got it? Okay. Now, notice I did say factor completely, and I haven't been doing that, although even if I just say factor, it means to factor completely. And so that should give us a little clue here that we're not done yet, right? So let's go way down here. What we have so far is x squared minus 9 times x squared plus 9. Right? So I just copied that down here. Yeah, so what's wrong with that? Right? Why is that not the answer here? So look at carefully the first factor, the x squared minus 9. Because remember, x squared is certainly, oops, put the x in first, a perfect square. And 9 is 3 times 3. So 9 is also a perfect square. Right? So we can go further here. Right? This is also a squared minus b squared. But now my a is just x and my b is just 3. So different a and b from the original problem. The original problem, a was x squared, b was 9. Now a is just x and b is 3. So when we factor a squared minus b squared, we get a minus b times a plus b. Right. So x squared minus 9 factors as x minus 3 times x plus 3. Right. What about x squared plus 9? What does that factor as? Remember, even though it's perfect squares, it's a plus. A squared plus b squared is prime. So we cannot go any further with x squared plus 9. Right. So this is it now. We're done. Okay? So essentially, for this problem, we had to use this formula, the a squared minus b squared, twice. First, when a was x squared and b was 9, right? And then again, when a was x, right? And b was the square root of 9, b was 3. And we did that down here. Right. Right. Yep. So the point is, if you leave your answer right, like this, you will get partial credit because it is factored, but it's only factored partially, right? So you're only going to get partial credit. Down here, this answer will give you full credit because it is factored completely. Right? So just keep that in mind. Okay, so yeah, this was a little bit of a tricky one because it was factorable twice by using right, this formula here. Okay, that doesn't happen very often, but it did happen here, so just be aware of that. Okay, next one, 6a squared minus 96b squared. Okay, so this one's also a little tricky, right? Because this is, right, I'm using lowercase a and b here. That has nothing to do with the capital A and B. And this is why I use capital A and B when I'm writing down the formula here. Because in some cases, you will see in the homework maybe lowercase a and b. So don't get confused with the uppercase a and b. Right. So the next thing, right, so this is a difference. It's not a sum, but we're looking for perfect squares, right? and 6 and 96 are not perfect squares, right? They're not perfect squares. The square root of 6 and the square root of 96 are decimals. They're not whole numbers. Right, so you might think, well, then that means we're done, right? The GCF is 1 and that's it. But the GCF is not 1. The GCF is 6. 96 divided by 6, right here, is 16. Right? So that means we can factor out a 6. Okay, and that's 16. So 6 times a squared minus 16b squared, right? So yeah, don't forget to factor out the GCF first. In this case, just the 6. But we can go further now, because 16 is a perfect square, right? And so is the 1 here in front of the a squared. Right? So that tells me that we're going to have a squared minus 4 times b squared. Right? So in other words, my a, capital A, is just little a, and capital B is not little b, it's 4 times little b. Okay. So with that in mind, oops, sorry, I didn't mean to use green here. Stick with yellow. Right, so this should factor as a minus b, or sorry, capital A minus capital B, so little a minus 4 times little b, times capital A plus capital B, so that's lowercase a plus 4 times lowercase b. And now I think we're done. Now I think we're done, right? And you might wonder, wait a minute, what about 4? Isn't 4 a perfect square? Don't we have to go further? Well, yes, 4 is a perfect square, right? 4 is 2 times 2. But here we have a minus 2 squared times b, right? We would only have to go further if we had everything was a perfect square. This would have to be b squared. This would have to be a squared, right? It's just the 2 that's squared. The a and the b here are not. So, nope, that means we're done, right? That means we're done. Even though 4 is a perfect square, these two terms are not. The a and the b. Got it? Okay. All right. I'll let you try one more. Okay, 3y to the 5th minus 48y. Okay, so again, not an easy one, but if you can get it, I think you'll be fine. This is about as hard as they come. Again, maybe the numbers could be a little bit bigger here. I could have made the numbers bigger, but I think it's fine. All right, so GCF. Right, GCF is 3 and a y. They both contain a y. So the GCF is 3y. Factor out the 3y from both terms, and you're left with y to the power 4 minus 16. Yep, just 16. We factored out the y, right? Okay. So that's the first step. Now, is there anything we can do with this y to the 4th minus 16? Sure. Y to the 4th is y squared squared, and 16 is 4 squared. Right? So my a is y squared, and my b is 4. So that tells me, and I don't need this square bracket anymore. I can factor this as y squared minus 4 times y squared plus 4. Okay. And look, if you got that far, you're almost there, right? It's still not done yet, though. The reason why it's not done is because y squared minus 4 squared, remember, sorry, y squared minus 4 not 4 squared, y squared minus 4, but 4 is 2 squared. And it doesn't matter here because this is a sum, and the sums are not factorable. So we'll leave this as y squared plus 4, right? Because y squared plus 4 is prime. Nothing we can do with that. However, the y squared minus 4 is not prime. We can factor that as the difference of two squares again. Here a is y, and b is 2. Right. So now when we write a minus b times a plus b, we're going to have y minus 2 times y plus 2. Right. And just to be clear, that came from this, right? The y squared minus 4 factored as y minus 2 times y plus 2. Okay, so there it is. Let's write it again. 3y times y minus 2 or y plus 2. Remember, order doesn't matter. And then y squared plus 4. Right. I know my 4s look like y sometimes. Sorry about that. Right, and that's as far as you can go. Remember, the y squared plus 4, y squared plus 2 squared is the sum of squares, which is prime. All right, I hope that does it. Right, so that's the difference of squares. So the thing you have to remember here, a squared minus b squared is a minus b times a plus b. I think that's not too bad. And of course, a squared plus b squared is prime for our purposes. For everything that we do in this class, it will be prime. Okay. Right. So if you want to know when is this not prime, that's a much more advanced course. We're not going to get there, so I wouldn't worry about it. All right, good luck.